Okay, so really quickly, I wanted to kind of dive in a little bit more um, into the high res, UV kind of setup. So I made some changes to the file that I showed in that video where I was talking with Michelle. I'm just cleaning this up just a little bit to kind of get rid of some of the noise, things that we don't care about as much. So, one of the things is like, how do we create detail and then have a low res proxy version? And so, in this process, we went through and we had our tube, right? And I'm going to turn back on the wire shade over smooth. So we had our tube. We came through here and we, added some attributes. We fused it, and I was doing some different things, trying to kind of talk through. Like, I've seen some stuff where you like move the geometry into UV space, and so I was doing a few things and playing with that. But I found this, which I sent the video over in the tutorials page, but it was fairly elegant. So if we use the subdivide and kind of crank it to get some high res detail, where we can then create, some of this really nice looking, uh, bump type stuff, right? So if we come into this Vex setup, we add a couple of layers of, all right, and rough it up a little bit, where we get something that's, kind of gritty. You can see there's a couple points that kind of freak out a little bit. Maybe we don't want that roughness. Yeah, that's better. So there we have there's our object, and it's got some few things that we probably need to clean up in the model, but it gives us this kind of cool gnarly tree, right? It's all twisted and gnarled, and we probably really play with that. So you get this kind of twisted tree. Something like that. That feels interesting to me, right? So now that I've got this, I want something that's lower res, right, that I can use this with. And so, following some of that stuff in that link that I showed you, it's about converting that data into onto a height field. So this is just a 1x1 height field. Our resolution is controlled by the number of grid samples. By setting this to bi-axis, will give us grid samples. And so here it's 4K. And then we create some information to copy information into. So normals n.x.y.z, color cd.x, cd.y, cd.z, position x, y, and z, and prim. And then it runs through this little bit of code here that takes those attributes and looks them up. So now, like when we look at this, we're able to, based on the geometry that we're feeding in, we can see the information for the prim UV, which is each primitive, each polygon, right? Each face has a UV coordinate system, right? That tells how texture is moved over that, right? So each one is a full set of UVs. So this isn't like the UVs of our object that we mapped out. This is the UV of each primitive. And so what we can do with this information now is we can look up attributes based on the primitive ID, which we've stored, and the primitive UV. So now we come into this bit of code where it takes that prim UV and it's taking and saying it's equal to this, which is CD, which is what we get from this visualization. It's moved that data into color. So we take that color, we turn it, we equal that to our prim UV. For our prim, we unpack the data that we generated here, right, in this prim. And then what we're going to do is we're going to look up, based on the prim UV, these different attributes, the normal, right, based on its prim UV and its primitive. So we're going to, for each primitive, each voxel, we're going to look this information up. And we're going to spit out the normal, the color, and the position. And once we do that, we just put a null for this volume, and we go into our cop network, and we use the SOP import, and we go and we get that volume. And then we can just click set resolution from SOP and set planes from SOP, and it will go ahead and create all this stuff that we need, which is what we've just generated. And then essentially what I did was I took a basic color, which was 4096 by 4096. I did a channel copy, and I took the target. So I want to target the color, and I want to source, which is my second input, this input number 2, the normal, and that made that the color my normal map. And then I just deleted everything else. I deleted non-scoped planes, said just keep the color. That way it's lightweight, so I'm not carrying too much information. Now, whoops, too far. Now I go into, and I create a material, and I create a material network and a material assigner. So here's my principled shader, and I use this op colon and then the path to that normal that I just created, which was here in the composite view. This is the normal. And so then I come out to this, to my material, and I come from here, which is my lower res version of the tree. It's before it's gone through the subdivide and this guy here, which, you know, granted changes the profile of that. But now we can take that low res and we can apply the normals of the high res tree to that. And we see there's a couple little like yucky points there that's happening from we're over displacing and getting that stuff kind of gummed up. But you can see how we can use this to create a very high res model and then take the normals off of that model and transfer it onto our lower res model. And so long as the UVs line up, it doesn't really matter what that geo is. And it gives us something that you can create some higher resolution information, you know, that we couldn't do this otherwise, you know, with this geometry. And so we would either have to do that with displacement or all in the shader, or in this case where we're sculpting and modeling and being able to build something out. So it gives us a lot of flexibility as far as how we want to go about creating things. It's just another way to do stuff. So it's something to think about as you're building and sculpting, is how do we generate low res and high res versions. And I don't typically like to use poly reduce or you know, those kind of things, but we can, right? So let's look at this and do poly reduce. So we can take it off of here. So here's our high res sculpt, right? So we could take that and reduce it, and let's keep 5% of our polygons. And so now we're starting to get that model. And the problem is you get some of this weird stuff, right? So we're going to rebuild our normals. You can see some kind of yucky polys that creates. This is why, you know, when you're doing this procedural modeling, you can get some kind of gross stuff that happens if you're not careful. And we can build systems to help clean this up, but it's hard. It's hard to get that to kind of fix itself. So maybe we do, let's keep 3%. And then let's do a smooth. So now we got the general shape of our tree. There's still a couple little gnarlies in there, but that's okay. And now we'll take that and apply our normals. You know, both are viable ways of going about this. So, you know, this is 2,000 polygons versus 96,000. So, you know, that's going to be a big savings when you put this into a game engine. We still have these kind of areas that we would have to kind of smooth out, which really is probably being caused by this here, which is our how much curl we're adding. Right, if we just reduce this down some, and you'll see this takes a minute to calculate because it's going to run through that whole chain all over again. It's cooking there. So if we're not doing some of that like bending stuff where it causes it to pinch, now you can see we've got something where we're able to keep our high resolution procedural data that we've just created, and we have actually a pretty nice model there as far as like building our tree. That's pretty slick to be able to generate that from those two. So something to think about, there's actually different ways to do this. There's another way using cops, and I had begun to kind of show this with Michelle and was saying I'd have to look it up, and I'll still look for that way because it's another interesting way of doing this where you kind of take geometries and line them up based on their UVs, like cut them up and line them up, and then you're able to capture that to texture and then reapply that. But pretty cool what we're able to get out of this. When you look at that versus that, we're capturing most of that detail. And if we, again, this will take time to do, but if we take our height field, and I'm going to pause this so it doesn't update manual. So we'll take this and let's make this 8K. Oh, sorry, it's 81. So 4096 becomes 4096 times 2, 8192. That's what it was. 8192. So we're going to come in here and we're going to change a couple things. We're going to change this to be 8192, 8192, and we're going to come back in here, and that's same thing, 8192. And we could link all this so that way we could change it on the fly and update things as we want. But so now we're going to regenerate and see what it gives us. Oh, haha, I didn't like that. So let's look at what this is. All right, so it was just a caching issue, but went through, and this is with it having an 8K texture map. So driven from here, which it looks like we probably can come into this and go to our surface color. And let's just make this 1 maybe. Oh, that's too much. So there we go. So you can see that it's holding most of that detail that we were taking before. So for something organic like a tree trunk, you can see how much we can. And again, I wouldn't do this for the hero level stuff where you'd be up like this. I would, in that case, default to our actual model, which even that, isn't that great, to be honest. So, but again, you look at how much we're able to maintain. It's pretty impressive. Hope this helps.